So next what we'll do is first briefly show you what we have here when we're setting up these problems. So on this side you have global definitions where if I right click, typically the only one I use is parameters. So if I left click parameters, I get this kind of option here. So you can put things like material parameters. So if we're going to put K is thermal conductivity. Whoops. Come back over. So thermal conductivity and specific heat. So I just put in some arbitrary numbers for now. We'll come back to those later. Next is the model. So inside the model you put in certain various types of definitions. If you right click, you have a large number of options here. We'll come back to this in a minute. Typically the first thing we do is set up a geometry. So you notice if I come back to here when I was on definitions, if you look up here, there's nothing here. Click on geometry, now you see some options. So we can put in points, we can put in lines. So remember this is 1D. 2D you can do other things like circles, squares, etc. Once you have this, you can also do things like join lines, you can intersect lines, and you can take the difference between lines. We don't use that much in 1D, but it becomes useful in 2D or perhaps 3D for creating more complex structures. Okay, so I'm going to left click here and I'm going to draw a line. I want a line that's from 0 to 1. I'm just going to click an arbitrary point. So I clicked these 2 points and I created this line. If you come back here and now left click on interval, you notice my left point was at 0, my right point is 0.8. So I'm going to change that to 1. So anytime you're inputting these numbers, to actually get this to execute this change of number, you have to build selector or build all. So I'm going to build all, and now you notice this has gotten longer. If you want to see the whole thing, you notice this zooms the extent. Okay, so now we have a line from 0 to 1. Alright. Next thing, weak form PDE. Okay, so if we click here, what you see inside here is the default version of your weak form PDE. So this is what goes inside the integran that we've discussed in class. So I'm going to delete this part and I'm going to put S here for source. So this could be a heat source that goes over this entire range. We'll come up with a variable for this later. We're going to change this to be Q. So Q is my heat flux, and this notation here, test, and then this in parentheses, test is my test function or weight function, and then the interpolation functions for Q are inside here. So we never see this. It's embedded inside the software. Other thing to point out is, remember, T is our independent variable. The reason X is here is that means it's a derivative of T with respect to X. Okay? The default boundary conditions are 0 flux. So this means there's 0 heat flux on both ends. And we decided to do a time-dependent problem, so our initial temperature and initial rate of temperature have been both set to 0. Right?